Hello everyone, I'm Anjali, housing my BTech in Computer Science and Engineering in Cybersecurity at SVC Bengaluru. So in the last video, I have discussed the following topics: programmer defined types, attributes, rectangles, instances as return values, object mutability, and copying in Python. In my today's video, I will be discussing about programmer defined types, attributes in Python, and instances as return values in depth. Coming to the programmer defined types in Python, they are referred to the custom data types created by developers using Python classes, and hence they play a very crucial role in modeling the real world entities or abstract concepts within the code structure. For example, attributes such as make, model, year, methods such as start engine and drive. Coming to the advantages of programmer defined types, they enhance the code organization by encapsulating the related data and behavior within a single entity, hence organizing the code. They also promote code reusability through the creation of reusable templates and reduces the redundancy in the code base. Coming to the attributes in Python, they are the properties or characteristics associated with an object. Objects in Python can have attributes that store information about them. These attributes can be variables or methods that belong to the object. There are two types of attributes in Python programming. We have discussed this in an earlier video also. Those are instance attributes and class attributes. Today I will be discussing these two in depth. Coming to instance attributes are specific to an instance of a class and are defined inside the constructor method, such as init of the class, and are prefixed with the self keyword to refer the instance. They also represent the state of the object and can vary from one instance to another. For example, coming to the example I have provided here, we have defined the car in the class, defined init with the keyword self, make and model. Self.make is equals to make and self.model is equals to model. These are the instance attributes. Then my underscore car is equals to car, Toyota and Camry. Print my car.make. This is how we access the instance attribute. Coming to class attributes, they are shared by all instances of a class and are defined outside any method in the class and are typically placed at the top of the class definition. They represent properties that are common to all the instances of the class. Coming to the example, we have defined dog in this class, species Canis familiaris. This is the class attribute. We have defined name and age of the dog with the self keyword. Self.name is equals to name of the dog and self.age is equals to age of the dog. These are the instance attributes, and this is how we access the class attribute by using my dog is equals to dog buddy and 3, print my dog.species. Coming to accessing the attributes can be accessed using dot notations. So using the syntax object.attribute. For example, to access the color attribute of a car instance, car_instance.color. Hence, this accesses the attributes. Coming to the best practices to access the attributes are to adhere the naming conventions for clarity, using lowercase with underscores such as p_limit, and enhancing the readability and following the Python conventions. Mastering the attributes, such as dynamic attributes, they add the attributes to instances when needed and enhances the flexibility of handling different cases. They are attribute relations. Utilize del to remove attributes, promoting efficient memory usage and decluttering class instances. And there are three types of attributes, such as class attributes, instance attributes, and read-only attributes for varied use cases. Coming to the instances as return values in Python. In Python, functions can return various types of values, including instances of an object. Instances refer to individual objects created from a class. A class is a blueprint for creating objects, and an instance is a specific occurrence or realization of that blueprint. This thing we have discussed in an earlier video also. And when a function returns an instance, it means that the function is responsible for creating and initializing an object of a particular class. And it has that object back to the column. This is a common pattern in object-oriented programming. This is the example I have given here. In this example, we have defined car in this class with the self keyword make and model. Set.make is equals to make, set.model is equals to model. We have created an instance of the car class. New underscore car is equals to car, make model, returning the instance using the return method, new underscore car. This is how we call the function and get an instance as the return. In this example, the create underscore car function takes make and model as parameters and creates an instance of the car class using those parameters and then returns the created instance. The caller of the function receives an instance of the car class and can use it to access and manipulate the attributes of that specific car. Returning instances from functions is a powerful and flexible way to structure the code. It also allows for encapsulation and helps adhere to the principles of object-oriented design by keeping the creation and initialization logic within the relevant class or function. Coming to the use cases and chaining methods, flexible object creation, configurable initialization. Instances as return values facilitate dynamic and customizable object creation. This is the flexible object creation. Ideal for situation requiring pre-configured instances with specific attributes is the configurable initialization. Coming to the chaining methods, method chaining allows multiple method calls on a single object in a concise manner. This is enhancing the readability. Coming to the streamlined workflow improves the code readability and simplifies the complex operations through the sequential method calls. Mastering the chaining methods, master the art of method cascading to streamline code by executing multiple methods in a single line. Ordering the matters by understanding the importance of method order in chaining to achieve the desired behavior and prevent unexpected outcomes. Emphasizing how the method chaining improves code readability by presenting operations in a clear sequential manner. This is how the readability benefits the code. Coming to a quick recap of this video, programmer-defined types is crucial for structuring data and enhancing the code usability. We have also discussed the attributes and defined the object properties, adhering to naming conventions for clarity. We have also discussed instances and return values which facilitate the complex object creation and return method chaining. Coming to the few tips of Python, embrace duck typing for flexible coding, leverage decorators for code modification and extensions, and exploring the data classes for simplified data storage. Coming to the fun Python fact, Guido van Rossum's inspiration from Monty Python emphasizes Python's simplicity and readability. Thank you so much for being till the end. Do like and share.